Have you ever stared at your phone like this is a magic rectangle and I have absolutely no idea how humans create such wonderful, terrible objects? Me too. This video won't talk about how to build a phone. However, we will discuss the basis, the building blocks for all electrical devices. Basic circuitry. If you understand the basics of electronics, not only will you pass your IB exams, you'll also come one step closer to cracking the corporate black box of technology. This stuff isn't that hard. Let's begin with a couple definitions. A circuit, as defined by techterms.com, is a closed path that allows electricity to flow from one point to another. Now, there are two key terms in there. To be complete, a circuit must be closed. In simple circuits, that means that the positive end of a battery must always end up connected to the negative end after passing through a variety of components. Additionally, we can define electricity as the flow of charge. Electricity in a circuit can be broken down into four key terms: volts, watts, amps, and ohms. These are all units of measurement used to describe different phenomena in circuitry. First, let's recall our SI units. One we haven't used much so far is the ampere. The ampere is a measure for electric current, which in turn counts the number of electrons flowing through a circuit. We can use a handy little analogy to describe how these work. Imagine a pressurized water tank attached to a hose. If you increase the pressure, the water will contain more potential energy, and when released, will flow faster. This describes volts, defined as pressure from an electrical circuit's power source that pushes charged electrons, or current, through a conducting loop. In IB terms, volts are equal to joules per coulomb or watts per ampere. Now, if you step on the hose or otherwise restrict its size, the water's flow will be limited. This describes resistance, which is measured in ohms. Ohms have this cool little symbol that I think is neat. Ohms are equal to volts per ampere. Now, we know what the water is like in the tank, but once it's out of the tank, that's what current is. The combination of the volts pressure and the ohms resistant. Current, as previously mentioned, is measured in amperes. It can be described by the equation I equals Q over T, where I equals current, Q equals the quantity of charge flowing past a point, and T is the time period. Finally, we arrive at watts. Watts can be calculated by multiplying the circuit's voltage and current to arrive at the total power of the circuit. P, power, measured in watts, equals VI. These can all be related to one another through a handy formula known as Ohm's law. Ohm's law states that V equals IR, voltage equals current in amperes times resistance in ohms. In other words, Ohm's law is such that it takes 1 volt to push 1 ampere of current through 1 ohm of resistance. An alternate configuration is I equals V over R, stating that the current in a system is equal to voltage divided by resistance. So, that's all kind of boring. I promise that circuits aren't just math. Unless you like math, in which case, they totally are. Let's introduce some components. This is a 9-volt battery. It has two terminals, a positive and a negative. To form a complete circuit, the positive terminal must eventually lead to the negative terminal. Current cannot flow without this connection. That is, unless you're talking about AC current. The two forms of current are AC and DC. I won't make the joke. DC is likely what you'll be dealing with while doing circuitry in this class. AC deals with alternating polarity and is also quite dangerous. Alternating the polarity in your body is kind of not fun. AC is what comes out of your sockets. These are the symbols for battery connections. This is a resistor. This gives us the hose blockages mentioned before. Measured in ohms, they restrict the flow of current. In practical applications, these are really useful to bring your level of current down to match the components you're working with. Too much current can fry a part of your circuit, and too much current sent straight to your battery will cause a short circuit, rapidly depleting the battery's power and heating up a lot. So these guys are important. This is the symbol for a resistor. Resistors actually lead us to a nice formula on our equation sheet. The formula R total equals R1 plus R2, etc., is referring to resistors connected in series. This is pretty logical. If I have 3 10-ohm resistors connected back to back, the total resistance will be 30 ohms. However, this is just one way to configure resistors. Another way is to connect them in parallel. If our resistors in series were one long connected wire, our parallel resistors are a section of wire split into 3 parts and then forming one wire again. The resistance of these is calculated as 1 over R equals 1 over R1 plus 1 over R2, etc. If we had those same 3 10-ohm resistors connected in parallel, their overall resistance would instead be 3.3 repeating. These are breadboards. One second. There we go. It's pretty much what you use instead of a ton of wires. This is what it looks like inside. Any component placed on one of the long gray metal rails will be connected to another component on the same rail. We can see that the rails on the inside are vertical, while the longer outside rails are horizontal. The horizontal ones are called power rails and are used to power the circuit through a battery connection. There are lots of other components out there: capacitors, LEDs, potentiometers, diodes, buttons, switches, the list goes on, but let's keep it simple and just talk about these. To close it off, here's some fun circuits. Because let's remember, circuits are the basis for almost everything. Therefore, we can do almost anything with them. So let's get some key takeaways. Electricity can be described using volts, watts, amps, and ohms. These are all related using Ohm's law, which states that V equals IR. Resistors in series can be added together, while resistors in parallel can be added using the formula 1 over R total equals 1 over R1 plus 1 over R2, etc., etc. We looked at a couple schematic symbols and how to look at a breadboard. Finally, we saw that circuits are way more interesting than they might seem, and that understanding these concepts means unlocking an unlimited world of weird electronic creativity. So while I haven't taught you how to build a phone, I hope I've at least shown a couple ways you can have fun with electronics. Thank you.